2.3, functions. A function is a relation in which each x has one y. And you can see down in these mappings, the easy one to see that's not a function. When this 6 splits and hits two different y values, that's not a function. Okay, that's no good. I like to look at it as throwing darts. Okay, think about throwing darts at a dartboard. It's perfectly fine if you throw a dart and then another dart and both of those darts hit the same target. That's perfectly fine. That's a function. But what's not fine, what's not possible, is to throw one dart and hit two different targets. That's why this one is not a function. Which of the following are functions? So remember that little definition. Each x has exactly one y. And so you can think about it as a mapping. If you look at that first one, -4 goes to -3, and -3 goes to 1, and +3 also goes to 1. That's fine. That's a function. That's like two darts hitting the same target. That's fine. If you look at the next one, 2 goes to 3, 3 goes to 2, 4 goes to 5, 5 goes to 4. No problem. That's a function. But then the last one, you can see pretty quickly that that's not going to work. It's easier to see that it's not a function. When you've got -4 and -4 goes to 3 and -4 also goes to -3, that's not a function. The domain of a function is the set of all values of the independent variable. If you thought I was going to say the x variable, you were right. That's what we say a lot of the times. A lot of the times students say, what's the domain? It's the x number. And that's kind of right, but that's a limited definition because there's not always an x in your equation. You won't always be looking at x numbers. All right, it's the independent variable or the input value. The range of a function is a set of all values of the dependent variable. A lot of times that's the y value. One easy way of telling if a graph is a function is by the vertical line test. Example 2, give the domain and the range of each. So most people are going to go with the domain is the x numbers. And so you would just list out the x numbers, -4, -1, +1, and 3. The range is the y numbers, so -2, 0, 2, and 5. As for the last question, is this a function? You do the same thing as what we did above. Each x goes to its own y. Each dart, hits its own target. That's fine. That is a function. Yes, this is a function. You look at the next example, and I kind of like to look at it as like a mapping. Okay, forget about for a second. All of these go to 5. There are 4 darts and they all hit the same target. That's fine. That's a function. Okay, this is definitely a function. But the domain, -3, 0, 3, and 5. Those are squiggle brackets. And the range is just 5. That's it. You don't need to write it 4 times. Don't repeat it. So when we look at the graph, remember up at the top it says an easy way to tell if it's a function is by the vertical line test. Okay? You'll probably remember the vertical line test. You would draw a vertical line through like that. And if it only hits one time, it's a function, right? So that first thing, I'm going to get rid of that. The first one is a function. And the second one is not a function. You can tell by the vertical line test. It hits more than once.
The vertical line test? Is that when you just...
Right, the vertical line test says I'm going to draw a vertical line through, and if it hits more than once, that's like one dart hitting two targets, okay? Basically, let's look at this one right here. If x equals 1, then you've got a y value here and a second y value here. That's like your x going to two different y values, okay? That vertical line test is showing me that it's splitting. My dart is hitting two targets. That's not a function, okay? So don't forget domain and range. That's going to be important, and that's going to be something new, okay? Don't turn the page yet. We're not ready, all right? This is very important. This is probably the hardest part so far, okay? So if you think about domain as the x numbers and range as the y numbers, look at your graphs, all right? People kind of struggle with this, all right? You've got this parabola, the first one, but what I want you to do is visualize what would happen if the ceiling and the floor were closing in, okay? I want you to take your ceiling and your floor and completely squash that graph, okay? So, check it out. If I'm a parabola right here, all right, if the ceiling and the floor are closing in and squishing me, my parabola is going to get squished and it's going to turn flat like this, right? That's what's going to happen. If you squash that flat, it's going to end up covering the entire x-axis. I can squash that thing onto the x-axis, okay? So when I want to find the domain, the question is, what x's would be covered in that graph? And the answer is all of them. So this domain here would be all real numbers. We're going to write it in interval notation by parentheses, negative infinity to positive infinity. Get used to that because you'll write it a lot. So for the range, I want you to visualize the walls closing in, okay? Because I want to squash that one onto the y-axis. So if you took the walls and you completely squashed, if you squish that thing onto the y-axis, the entire y-axis does not get covered. It only covers from, basically 4 down, right? That thing squashed onto the y would be from 4 down. And so when we write the interval notation, we start with the smaller number on the left, that's negative infinity, and we go to the larger number, which is 4. And one other thing, since we could equal 4, we will use a squared off bracket, square bracket. Square bracket means it could equal the number. Parentheses means it can't equal the number. Since we can't equal infinity or negative, we use parentheses there. Okay, once you get the hang of that, it's easy, but it takes a second. Students kind of struggle at first. Look at the oval. If I was going to squash that oval onto the x-axis, it would only cover from negative 5 to 5. That's the domain. Equal negative 5 to positive 5 equals. Square brackets means it could equal. If you look at the range, you squash it onto the y. If you only look at the y values that would be covered, it would cover from what to what? Negative 3 to 3, exactly. And that's your range.